In this example, in this video, we are going to take a look at stoichiometry, and instead of just using moles to moles, we are actually going to be dealing with grams. So whenever you see a stoichiometry problem and it says grams, you know that's going to involve a little bit more work because what you have to do is you've got to convert your moles into molar mass using the mass numbers on the periodic table. So it's not necessarily more difficult. There's just a few more steps that you have to do when working with grams. A quick review. We set the molar mass of something. So the molar mass of something, the units of that is grams per 1 mole. So basically we're asking, if I had 1 mole of a substance, how much would it weigh? So let's say if we had water, if we had H2O, and I want to know the molar mass of water. So I'm asking how many grams are in 1 mole of water molecules. So to do this, I know I have 2 hydrogens and I've got 1 oxygen. There's no number here, but there's understood to be a 1. Well, I know that the mass number for hydrogen is 1.008. And I know that I have 2 of them. So 2 times 1.008 is going to give me 2.016. And I know that that's grams. For oxygen, so I'll put a H here because we know this is for hydrogen. So for oxygen, I only have 1 of them. So the mass number of oxygen is roughly going to be about 16. There's only 1 of them, so I don't really do this. I'm just, showing you what you would do if there were more than 1. But 16 times 1 is still just going to give me my 16. So then if I add these two numbers up, 2.016 plus 16, I'm going to end up with 18.016. And the units on this is grams per mole. So this 18.016 is the molar mass for water. And in order to find the molar mass, all that you do is you take all the elements in the particular compound you're looking and you multiply by the appropriate numbers. In this case, hydrogen was multiplied by 2. I didn't really need to multiply oxygen by anything because there were just 1 of them. But for the sake of being explicit, you see what went on here. 16 times 1 is 16. But anyhow, this is review. This is how you find the molar mass of a compound. So let's scroll down to a particular question. So if we look at this balanced equation, we have CaC2 plus 2H2O yields C2H2, and this actually should be a plus here. So let's kind of scratch that out and we'll say plus. Alright, so C2H2 plus CaOH2. So our question says, how many grams of C2H2? C2H2 is actually something called acetylene. It's a hydrocarbon. It's a gas. Sometimes it's used in torches for welding, cutting through metal. Maybe not welding, but definitely cutting through metal. But are produced by adding water to 5 grams of calcium carbide. So the first thing we're going to do here, in these particular examples, we are going to use the factor label method in order to do these type of problems. Now remember, we said factor label method is also called dimensional analysis. Maybe you could hear them referred to as fence post problems, but it's sort of the same. It's just a bunch of different names for the same thing. So I'm going to start out with what I get from the problem. I get 5 grams of CaC2. So I know that's what I'm starting with. So I want to cancel out my CaC2. If I take a look up here, the ultimate goal is to end up with grams of C2H2. So I'm looking at grams of acetylene, C2H2. So I've got CaC2 on the top. I want to cancel out, or grams of CaC2 on the top. I want to cancel out grams of CaC2 on the bottom. So if I've got the same thing here and the same thing here, these will eventually cancel out. But in these vertical slots, the up and down, I have to find values that are equal to one another. So in this case, I'm going to have to find the molar mass of calcium carbide. So I'm going to put 1 mole of CaC2 on top. And the molar mass of calcium carbide, CaC2, is actually 64, and we're going to round and say well, actually 64.1. We're just going to say 64.1 to kind of keep it simple. And once again, in order to find this number on the bottom, all I would do is take calcium's mass and add it to the mass of carbon and add it to the mass of carbon again because there are two of them. So I get 64.1 grams is equal to 1 mole. Now, once again, 1 is not the same thing as 64.1, but remember these two are equivalent to one another. It's almost like we've said earlier, 4 quarters is equal to $1. Even though 4 and 1 are different numbers, 4 quarters has the same value as $1, and these two in a vertical slot have the same value to one another. So let's go ahead and take a different color here, and we can see where this grams of calcium carbide will cancel out this grams of calcium carbide on the bottom. So if I take a look up at the top, I'm left with moles of calcium carbide. But I don't want moles of calcium carbide. I've circled what we want, which is grams of C2H2, and that's the acetylene. So we're going to go ahead and keep converting some units. So let me bring back my yellow. So I want to get rid of moles of CaC2. So in order to do that, I put moles of CaC2 on the bottom. And I know I actually want to go to this different compound C2H2, so I'm going to go ahead and put moles of C2H2 on the top. So this particular information here, where I've got the mole-to-mole ratio, this will come from the balanced equation up here. Whenever you have a mole-to-mole ratio, that comes from your balanced equation. So I know in looking at C2H2 and CaC2 on the bottom, it is a 1-to-1 ratio because I don't see a number here, I don't see a number here, so I know the numbers are automatically assumed to be a 1. So I know the ratio I can go ahead and put in down here is a 1-to-1 ratio. So I'm going to go ahead and put in my line. So choose my different color. So this moles of CaC2 will cancel out this moles of CaC2. I'm left with moles of C2H2. Well, I'm getting close. I want grams of C2H2, so I've got to go to one more step. So I want to get rid of moles of C2H2. So I'm going to go ahead and put moles of C2H2 on the bottom. Go ahead and extend out my line here. And I know I want to end up with grams, so let's go ahead and put this on the top. So I've got grams of C2H2 here. So now I've got to make this equivalent. So I know that my equivalency factor would be in 1 mole of C2H2. I need to find the molar mass of C2H2, and the actual molar mass of C2H2, we're going to go with 26.036. Okay, so that means I had 2 carbons. I added carbon to carbon, add that to 2 hydrogens, and then I end up with 26.036 grams. So now let's go back and cancel out some stuff. I know this moles of C2H2 cancels out this moles of C2H2, and the units that I'm left with are grams of C2H2, and if I look here, that's what I wanted. I wanted grams of C2H2. So once you get to the units that you want, you're done. Setting it up is the hardest part, because after this, it's just punching in a calculator to get your answer. So in order to get your answer, all you have to do is take everything that's on top and multiply it together. So I'm going to take 5 times 1 times 1 times 26.036. And when I do that, I'm going to get a number here. So I'm going to say, well, actually, let's find out what this number actually is. When I take 5 times 26.036, I end up with 130.8. And when I take 64 times 1 times 1, or 64.1 times 1 times 1, I end up with 64.1. So once you do this, once you're here, you have to divide the 130.8 divided by the 64.1. And when you do that, you end up with 2.03, and your units are going to be grams of C2H2. And you know that because that's what you were looking for up here, grams of C2H2. So the answer to this question using the factor label method is 2.03 grams of acetylene.